Hello, everyone. My name is Shoba Krishnan, and I'm the chair of the Department of Electrical and Computer Engineering at Santa Clara University. Today, I'm going to do a preview of my department and its programs. And for that, let's start off with these slides. So if you have any questions, feel free to send an email to skrishnan@scu.edu as it's listed over here. What I wanted to talk to you is about that electrical engineers enable devices we rely on every day. So if you think about all the different aspects of what we do, communication, which is phones and so on, speech recognition like Alexa and Siri, power, just the whole power grid itself, and then all the monitoring and sensing we do, whether it's for health or whether we do for the environment, this is something that electrical engineers are a big part of. But what are we thinking about in the horizon? So intelligent vision is a very important thing. So if you think about AR, VR, and think about surveillance and security, like in the airports and things like that. For this, you need computer vision, and all the algorithms and things that are done for this is done through signal processing, which are all concepts of electrical engineering. Telemedicine, which is seemed so important today with all this COVID-19 and things like that. It's so good if you would be able to send information about your health to your doctor who's far away. And this would be something that is really growing and is going to get more and more important as time goes on. Another important aspect of things that are very close to almost in production are self-driving cars. There's still a lot to be done from this. How do we know where the cars are? What are all the different computer vision concepts that you would have to do? How do we allow cars to go for longer distances? Having them electric, things like that are challenges that are there, but it's very close to production. Another thing is robot evolution. If you think about robots, few years ago, we thought of them only in industry like manufacturing. But now when you think about it, it's everywhere. You go to Target and you see it kind of walking around doing security and things like that. But what are all our challenges because of this? When we look at all the information and all the devices we have, there were only 5 billion just about 5 years ago, where everyone has a computer, everyone has a phone. Now your car is connected, maybe even your toaster, your refrigerators. If you think about it, you've gone from 5 billion to almost 50 billion today. So that's going to be a big challenge. And because of that, this is called the Internet of Things. What are the different things that come up? One, you have to store all this data, and that's called big data. That's a problem. The other thing is you have to connect all of them, and so you have very dense networks. And electrical engineers have to find the problem and solve it, and have to decide how are you going to be able to connect all these people without having any issues with communication? How are you going to store all this without getting out of space to do the storage? And besides that, there are 3 other concepts. Security, you're putting all your information out there. Are they secure? And it's not just a software problem. It's also something you can solve in hardware, which is hardware security, which is something we take care of in our department. Then power, you've got all these things, everyone's consuming power, all this electronics. How are you going to make sure that this has lower power and that you can run for a less energy, all these things? And when you do have energy, how do you store it? How can you come up with better methods of storage of your energy? So that's another important concept to think about. If you think about electrical engineering in other ways, it's truly interdisciplinary. So if you look at the pictures on this slide, you can see that we have robots that are with mechanical engineering, drones. All of these require you to have interdisciplinary functions. We work with the bioengineers on different aspects of medicine and self-health and things like that. But on the left side, you have some interesting concepts. So one is a plastic circuit. It's something that we can just make circuits on a sheet of plastic, and these flexible circuits, as they are called, we had to work with physics and chemistry majors to make sure that we can produce something that can be conducting and can be done on plastic and things like that. Then the other thing you look at here is these photovoltaic cells, and it's made out of something green, this lower left corner. And this thing that is here, this is actually made out of spinach. So plants are the best have the best properties for photosynthesis, and having something like this would make it more interesting to see how can you make it more sustainable. You can grow spinach any amount of times. It consumes less energy. So this is something that we have looked into, and there are many ways of finding out how you can work with biologists and chemists to come up with cells like that. So these are the things that show you that it's a very interdisciplinary major. Even if you decide not to do this specifically, you could do some other major and minor in this. The other option as electrical engineers is to minor in another discipline, so you get the breadth that you want beyond this particular aspect of electrical or electrical and computer engineering. The other thing I wanted to highlight is about the location of our university. So, we are in Silicon Valley. What does that mean? So everyone talks about it. I want to kind of define for you how exciting it is for being an electrical and computer engineer, why this is so exciting. So you open up your smartphone. I would tell you not to do this at home, but if you do open up the smartphone, I want you to see all the different components inside there. And if you just drive down one of the highways right here in Silicon Valley, you'll see all these companies. They're on the left and the right. So it's a very, almost like a religious experience for one of our majors, because you get everything you need, and all the companies that you would like to work with are right down the street. So it's a pretty good reason to come to Santa Clara, because you have connections with the valley. And you have a lot of places you can leverage all the resources that are there. The other thing that I wanted to talk to you about is our program itself. I've divided our program into different categories, and it's based on the 4 years, of course, but the first year I call it something where you're getting aware of your career. You learn all the supporting science and math, you get all introduced to a couple of things like logic design, and then you have this introduction course to electrical and computer engineering. And that course is something where its syllabus is right here on this right side here. And what you'll see in this syllabus is that we have guest talks from different people, and we also have visits to the local companies and connect with them and learn from them what's going on in the valley. What are the new technologies? What are things that would really be what you will see when you graduate from Santa Clara? So it's kind of be easy, and all these companies are just 5 minutes away from our campus, and so it's really easy to go to these places. The next thing I wanted to talk about is our second year, and that's, I think, the most fundamental year for the major. It has all the core topics in circuits, linear systems, electronics for the electrical engineers, and the ECN majors do embedded systems, computer architecture, electronics, and things like that. So you'll find that you're really building your fundamentals in your second year. And I think personally it's the toughest year, but we have a good cohort of students. We have small class sizes. So we have about 20 to 30 students that are going through this program together, and they have a good rapport and they work well together to kind of battle through this whole year that they go through. Then the next year is where you explore your career. You have a lot of hands-on experiences. You build different things in your different courses. And then you have electives you can start taking. And you take these electives in 5 categories. And they're listed here. And you might say, I want to learn more about IC design. And you can do more about it. But in all of them, you have projects. And it's really important that you get that experience of applying what you learn into something and building something. It could be physical, it could be simulation, but it's something that all our electives have. In your final year, a couple of things happen. One is advanced electives. You can start taking courses that are really advanced because you find out that you have an interest in electromagnetics and you're like, oh, antenna design is what I'm really interested in. And you can spend some time learning that. You can even do graduate courses in your senior year in this program. So that's really important, that we give you this opportunity to take advanced courses in your senior year and get you more ready for industry or for graduate school. The other important thing you do is senior design. It's a whole 1-year experience. And what's really exciting about this 1-year experience is you pick something you're passionate about and then you do it for the whole year. This could be community-based, like the ones I've listed here. For example, this disaster relief communications box was something we thought about after the fires in Northern California. We found out the biggest problem we had there was that they could not communicate. And so the students and I came up with this project saying, you know, we need to make some sort of like you have a medical kit. We should have some sort of an electrical engineering kit that when there's a disaster, you can go with that and you can run a program or you can get power and things like that. And we worked with the disaster relief people, the firefighters and so on, to define what this project is about. Then the other thing you could do is interdisciplinary projects. And here, these projects are where you could build anything, but you're not going to build it alone. You're going to build with other majors. So for example, you could build with computer engineers or electrical, mechanical engineers. For example, the project that's here, the water contaminant detection, was done with bioengineers who made a sensor. Then we built a circuit that activates the sensor and reads its data. We sent it to a phone that could look at the data and tell us if there were contaminants, whether it was not good to drink it, or whether it was okay to drink. We also did additional thing where we could put data in the cloud and put information. So if anybody wants to know what water contamination was all over the world, you could even have information on that. We got people from the Red Cross and so on connecting and telling us this would be a great thing to actually take to production. And this was something that a few students decided to do. The next thing we wanted to talk about were research-based projects. So you could be doing something in the Center for Nanostructures, which is here, right here, where you could be building carbon nanotubes for future technologies, or you could be doing energy harvesting chip design that a few students did with me on their last senior design project. So you could also work in the Latimer Energy Lab on various power system research projects. So there's a lot of opportunities to also do research as part of your senior design experience, or even research all by itself. The other thing I wanted to talk to you about were all the faculty and their diverse backgrounds. We have about 15 faculty members. They're all experts in different areas, as I have listed here, and they've all done different fields that are exciting, and they want to work with students, both undergraduate and graduate, on research. And you find that that's an opportunity you get at a school like Santa Clara. The other part of it is our facilities. I know it's kind of a shame that you won't be able to visit our labs this year, but here are some pictures about all the good instrumentation and things we have. And even more exciting are all the industry standard tools that we have here that will have been so useful, especially this quarter where we have done everything online. We've been able to do a lot of projects just using software tools and having a good learning experience from it. The last part I wanted to show about facilities was about our new building. You can see that it's going to be coming up, and if you come this fall, the first year you're going to be in our temporary quarters, and then when we go into the new building, we are on the 4th floor. We have 5 research labs and 5 teaching labs, and I call it the penthouse suite, where we have all the different labs and everything together. So it's going to be a very exciting new space for you if you join Santa Clara. There are a lot of department initiatives that we have been going through. One thing is advising. We have very small classes, and so a lot of the students get a lot of personal attention. We do a lot of group advising, and like I said, it's a close-knit group, and we get to talk to each other and work with each other. We have a very strong industry mentorship program. Almost every student has a unique mentor if they want it, and this professional network, they come in, they give workshops, they do different activities with the students and help them develop professionally. The next thing is an internship program that I've been trying to get off, which is not just the summer internships that are there, but also try to get 6-month internships for the students in their junior year. You know enough to do a good internship, and sometimes you want to do it longer than just the summer. So I've been working with a few companies to give a longer experience for the students. The other initiative we have is we are trying to get more diversity into our program, and we've got an endowment going to try to get a 5th-year bachelor's and master's to be able to get your master's program in your 5th year to get that degree. And we are trying to get scholarships for especially students of diversity, women and minorities, to be able to support their 5th year. And of course, we have our professional societies. Our IEEE student chapter is really very, full of different activities and ideas, and they're always having a meeting. They have a meeting every week on something or the other. So it's a pretty diverse kind of thing that you could get out of experiences from them. I want to touch on the ECEN program because it's new. I wanted to let you know that it started it last year, and now we have one student that switched into it, and he's going to be graduating this year with this particular major. So while it's not accredited as of now, it is going to be very soon because we already have our first major. And there is such a demand for the engineers in this learning embedded systems and hardware aspects of the computer engineering. And so I think this is for people who like that aspect, should definitely think about looking into this part of the program. After graduation, where do our students go? They go into industry, and I've listed all the different places they could go. They might go to graduate school. They may go to graduate school at Santa Clara, do a master's degree somewhere else, but many of them have gone on to do PhDs. Besides that, they also might go into business school. They may do patent law. They might do medicine. So you never know where you would go, but an electrical engineering background really gives you a broad base for you to be able to leverage that and go anywhere in your career. So what I want to do last is to introduce you to a group of students, and I have a panel of students that will join us, and then they will be definitely sharing their experiences with you about different topics and different questions that I have listed, and that's a separate video that you could watch. And finally, if you have any questions, here is information about our department, and anything you would like to contact me, here is the email address that you could get in touch with me with. So thank you again for your attention, and I hope that you connect with me if you have any questions, and I hope to see you in the fall.